Okay. So, what we're going to do tonight is we're going to try to finish out chapter 6. So let me give you an example problem that we're going to be talking about. If it took, so I'm going to buy this, let's see what I want to talk about. Insecticide. I'm going to put this stuff on my lawn. I'm going to spray it on my lawn. You with me? I got some kind of weird creatures in my lawn. I want to kill them.
A whole bunch of them, groundhogs and cormorants and whole lawn.
I'm sorry. Yeah, we got some of those out front too. They suck. Every time you go out, you like to have a whole new hole to go into.
This is doing Monsanto, I don't want to hear about it.
Dealing with what?
Monsanto?
I have no idea what that is.
Monsanto is the guys taking over the crops and sending insecticides and putting GMO in all the foods.
Oh, no, I won't go there because I didn't know who that was. So if it takes 5.2 liters of this insecticide for every, let's say 40 square feet of lawn, that's a lot. Let's say 400. It's like, how concentrated does it have to be? For 400 square feet of lawn, you with me?
What's that thing up there too?
Oh, let's use gallons.
Okay, gallons.
So liters is a metric unit, which we're one of 3 or 2 nations in the world that don't use it. Anyway, I'll get past it. So if it takes 5.2 gallons for every 4, now that by itself, that's section 6.2, or even 6.1, I can't remember now. 6.1, create the ratio. Can you write the ratio that represents? How do I write?
Over 400.
Yeah, 5.2 gallons over 400 square feet. Right? And I could reduce that in all kind of grammar. We're not going to do that right now. But I have, well, my lawn is 1,348 square feet. So how much of this do I have to buy? How many gallons of this should I buy? That's the question, right? And there are a few different ways to do this. I'm going to show you the standard textbook way. If you have some other way to solve this that works, as long as you can see your work, I'm cool with it. Here's a standard textbook way to do this. You guys told me 5.2 gallons over 400 square feet. So can somebody answer this question? If it was 800 square feet, how many gallons would I need?
10.4.
Where'd that come from? Yeah, if I have twice the square footage, I need twice the amount of insecticide, right? That seems simple enough. So that ratio has to hold. So the question is, it's not 800 square feet, it's 1,348 square feet. And how many gallons do I need? I have no freaking idea. So I'll put a big ass X there, right? Or small. You guys with me? So now we're merging the ideas from 6.1 and 6.2. We're using ratios to create equations. And we actually call this type of an equation a proportion. So each one of these is a ratio. When you set ratios equal to each other, that is called a proportion. And then how do you solve a proportion? Well, we already know. We've already gotten practice at it. You just cross multiply, right? So let me take the units out of the way so we can do some pure math on this. So how do I cross multiply? What do I do?
5.2 by
1348 times 5.2.
Okay, 1348 times 5.2.
X.
Somebody help me out.
And then 400x.
Good. So on the other side would be 400x. I'm just doing textbook, the pure thing. There's a lot of shortcuts you can take to this, but I'm not going to.
What you want to do is your amount that you get at 5.2, 1348 is going to be the left of the equal.
Now help me out. Somebody help me out. Who's got a calculator out and ready? What's 5.2
7,009.6.
Do it again, sir.
7,009.6.
Oh, okay, too many.
7,009.6.
7,009.6?
Yeah. And then divide
Yeah, and then you divide by,
400.
because you want your x by itself, right? Good. So x equals whatever the hell that is.
17.52.
17.52 gallons. Cool. You kind of with me?
No, what did you do with the 400?
Killed
You
it.
just made 400.
Divided it. So again, I got to this point here. Cool, right? By doing this times this, bam. This times this, bam. Why is your x not by itself? Because that's my whole goal when I'm solving an equation, is try to get the variable by itself. Why is it not by itself? What's with it?
The X.
No, why is the x not by itself?
Oh, 400.
Good. So how do you kill the 400? You want that x by itself. How do you cancel it? You divide it, because the 400 is currently multiplying the x. So divide by 400 both sides. Because that would definitely cancel that out. So then whatever the hell that is what x is. So if I can get x by itself, whatever the number is on the other side is the answer. Because where did I put x? I put x right where my answer would be. So if I figure out x equals 17.52, that's my answer. And it kind of makes sense. Isn't this a little more than 3 times? 3 times 400 would be 1,200. So it's a little more than 3 times. 3 times 5.2 is about 15. 15.6. So 17 makes sense. It's a little bit more than 3 times as much. So you can make sure that your answer makes sense. You guys like it. I can tell.
So where does square root come in?
That's coming in the next section.
Next chapter.
Yeah. So, which part of this was difficult? This ratio, they always have to give you one complete one. So you can set that ratio up. I put gallons on top, square feet on the bottom.
Could be page 429.
So when you set up the ratio that you don't know everything, you got to put square feet on the bottom. Okay, I know the square feet. And you've got to put gallons on the top. Shit, I don't know gallons, so you put an X there. Then should be the easy part. Then should be just cross multiply and get X by itself. And we should be getting better and better and better at general ways to solve equations. So normally setting the equation up is bad. But solving it should not be the hard part. Right?
So I think if it's 400, basically if you cross multiplying, you do 400 times x, which is understood as 1. Why would it be 400x?
It is 400x.
Then where are you getting the 600 to put on the bottom?
How do you solve this equation? Divide by
2.
2?
Where'd you get the number 2 to put on the bottom?
Because it has to be the same on both sides.
So if you have 400x equals, I don't care, you're going to divide by 400. See, so what you just said is perfect. I don't care how weird or ugly or big this number gets. I'm going to divide by it. I'm going to divide by whatever the hell's there, I'm going to divide by because I know I want my x by itself. So you do not let the numbers tell you what to do, right? You know the problem. You divide by whatever it is, and then you just suck it up. Whatever happens, that's the answer. Thankfully, on this one, I will let you use a calculator, because what I'm more interested in on this is, can you set it up and solve it correctly? Not, do you understand how to divide decimals? Right? You can do that in the calculator, but I need to see the steps. Yes?
Can you do, in that chapter, can you do number 30? 6.3?
Oh, that's funny. It's another pesticide problem.
So where you have 7,009 over the 400, that's just because you're doing it on the other side?
Yeah, whatever you do to one side, you have to do the other side. If 400 of these equals that, then one of these must be 1/400th of this. It must be a quarter times smaller. I'm doing the same thing to both sides.
I'm just like, so what is x equals?
Yeah, so what is 7,009.6 divided by 400? 17.52. Okay. So let me look at that example. It's a little bit different. It still deals with killing insects.
That was the hardest one out of the whole chapter.
Really? All right, let's do that one. And then the rest of them should be cake. All right, so we got what they want here?
Yeah.
Okay. Probably more than you wanted. So this one says, so if you've ever had to do this, you know that normally you mix your insecticide, you mix it with water. You dilute it a little bit, because you put it on there, then you're going to kill like everything. You don't want to do that. So this one says 3 ounces of pesticide must be mixed with, where'd it go? 100 ounces of water. Okay. Blah, 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 blah. This mixture is sprayed on roadsides to control mosquito breeding grounds. Good, because mosquitoes are actually the deadliest animal on the face of the earth. They kill the most people. So let's kill them first.
So it'd be 150 over 5280?
So if one mixture of water can treat 150 feet. Oh, I like this one. All right. So part A says, this is number 30 by the way, in section 6.3. If one mixture of water can treat 150 feet, what's up? Oh, gotcha. One mixture of water can treat 150 feet. Now this is difficult. Maybe I made too big of a step here. The reason this is difficult is because there's several ratios. You with me? But notice, this whole mess here is one mixture. Right? To make one mixture, I take 3 ounces of pesticide and 100 ounces of water. That's one mixture. One of those mixtures can treat 150 feet. So how do I set up that ratio?
300 ounces.
3 over 100.
3 over 100.
Okay, so let's see. This is why this is a difficult problem. How do I say this?
3 over
Are
100.
they asking now? Let me finish the question. How many ounces are needed to treat 1 mile? Right. If one mixture of water with this pesticide can treat 150 feet of roadway, how many ounces of pesticide are needed to treat 1 mile? That's the question. So if I can figure out, now let me, this maybe was too big of a step. I should have taken little steps towards this. But if one mixture can treat 150 feet, then how many mixtures can treat a mile, which they tell you is 5,280 feet? Where do I put 5,280 feet? Because I've already set up where things have to go, right? That's one of the
Your X will
most
be on the top.
beautiful, because I don't know how many mixtures. So it'll be 5,280 feet, and I don't know how many mixtures I need to use. Now, some of you guys might realize there is a shortcut to cross multiplying. Why is the x almost by itself? Yeah, so instead of just cross multiplying, now you can cross multiply every damn thing and just attack it that way. Nothing wrong with that. But if I just multiply by 5280, won't my x be by itself? Okay, you guys don't like that. Sure. So let's try to cross multiply. 5280 times 1.
Same number.
5280, it's crazy. So I did my half. Now the other one's not that bad. 150 times x
150x.
is 150x. Now how do you get x by itself?
Divided by 150.
Divide by 150. Are you guys with me still?
150
The important-
is 35.2.
Oh, sorry. So x equals
35.2.
35.2. Mixtures, right?
Perfect.
Because that's mixtures, is what the units is so far. Now, let me just stop right there. You know how to set up ratios. Most of you guys were able to set the ratio up correctly. It's not difficult. You just take what they tell you and make it into a ratio. You just put it over each other. One mixture for every 150 feet. Then you set that equal to the situation you're in. Well, I have a whole freaking mile to treat, dude. It's going to take me a while. how many mixtures do I need to make before I head out there? Spray all this stuff out there, right? That's the so mixtures to feet. Mixtures to feet. So I'm always going to have one where I know everything. I know the top and the bottom. And the other one I'm going to have a part of it that I don't know. Which makes sense. And then I can solve that. So in this case we need 35.2 mixtures. So I have to do this 35.2 times. Does that make sense? If I mix 3 ounces with 100 ounces, I get 1 mixture. Then I mix 3 ounces with 100 ounces, I got 2 mixtures. Right? So I got to do this basically 36 times. Right? And then just treat a little bit more somewhere good. You guys kind of with me? You guys hate this, I can tell. This problem is difficult, Randy, and everybody, because it's got multiple levels to it. Right? So part A just talked about mixtures to begin with. Now, in every mixture, how many ounces of pesticide are there? In every mixture, how many ounces of pesticide are there?
3 ounces.
No. I know I need 35.2 mixtures. But in every mixture, how many ounces of pesticide are there? 3 ounces of pesticide, right? So if I want to know how many total ounces of pesticide I need, because I got a tap, turn the I got my water, right? We're in San Diego, I know, hopefully it never stops. But I turn my tap on, I got water, no problem. But I got to go buy the pesticide, right? So if I need 35.2 mixtures, and every mixture needs 3 ounces of pesticide, how many ounces of total pesticide do you need?
11.7.
I know what you did, you got to be careful. So let's try to set it up. So if I need 35.2 mixtures, and one mixture has how much pesticide? 3 ounces. You see how I can set up a proportion still? I have 35.2 mixtures I got to make. One mixture has 3 ounces. So for my 35.2 mixtures, how many ounces? I don't know. X. So then you can solve that. But I'm hoping some of you guys see, if I needed 2 mixtures, and every mixture has 3 ounces, how many total ounces would I need? 6. 2 times 3. If I needed 4 mixtures, I would need how many ounces of pesticide? 12. What do you keep doing? Multiplying. So if I need 35.2 mixtures, and each one has 3 ounces, 35.2 times 3. Isn't that what I get here? Cross multiply, what do you get? X times 1? X, that's crazy. 3 times 35.2, that's what we just said you had to do. Good. So you need 105.6 ounces of pesticide. Now, I really want to make this point. I jumped into that not realizing the levels that was in there. So that was definitely the hardest problem in this section, because it's got multiple levels of ratios, and that's just freaking us out. Yes, sir?
Where'd you get 5,280?
They told you in the problem that you have a mile,
okay.
and 1 mile is this many feet. Okay, weird. Let's take a notch down, right? Let's go back a step here. The other classic problem for this is a map. You're looking at a map and you have to use the scale on a map. Now I know Google Maps, hopefully you're not using Apple Maps, but Google Maps pretty much tells us everything we got to know, right? You type in, do you guys use Google Maps at all? I remember MapQuest when it first came out. That was exciting. You were never sure where you're going to end up with MapQuest. But turn left.
Was MapQuest
There's a wall.
Apple?
Huh?
Was MapQuest Apple?
Maybe. That would explain a lot. What a classic problem is, if I look at a map and I want to go from Townsville to Placenham, and on a map they are 6.2 inches apart. You with me? I look at my map. 6.2 inches. I'm like, oh, right, this will be quick. The scale says every 2.5 inches represents, oh, what you got, Jeff? I don't know. 70 miles. How we doing? You guys with me? So normally on a map, you wouldn't have those ugly numbers. It's too bad. You're dealing with a math dude, so I'm going to make the numbers a little uglier. On the map, you might say like an inch represents 12 miles. So put a little ruler down, and you're like, all right, it's about 60 miles because it's 5 inches. Right? So forth. So you take the scale, however it's given, and it kind of depends on how much you've zoomed in or out for the scale, of course, right? So they tell me 2.5 inches is 70 miles. What can I do with that? Every 2.5 inches is 70 miles. So I can set up a ratio. Exactly. A ratio equates two things. So every 2.5 inches is also 70 miles. Equals, so what's got to be on the top?
X.
6.2.
Because I know 6.2 inches, right? Inches got to be on the top. I've already said, so I could have turned this way. I could have had 70 miles over 2.5 inches, right? But then I would have to have miles over inches. It doesn't matter. As long as it's the same. So inches on the top, I know it's 6.2 inches. And how many miles?
X.
I have no freaking clue, so it's X. That's what I don't know. I want to know how far apart are those two towns. How long is it going to take me to drive there? Yeah, 6.2 inches, look, I can do that real quick. No, it's not good. Right? The Earth's not this, I'm sorry. So what are you allowed to do?
Multiplication.
Cross multiply. I mean, this is going to be it. You set the ratios up. One ratio, you're going to know everything. The other ratio, part of it, you're not going to know. Then you cross multiply. So you get 2.5x equals
400.
oh, 434. They said about 139. Divide by 2.5.
173.6.
And what's the units? You know I'm going to be a dork and put down the bananas.
And 2 point, okay, wait, what do you mean? 2.5x?
Yeah, 2.5x, you cross multiply. Cross multiply 70 times this is there. Then how do you get x by itself? You divide by 2.5. So here you get x, and here you get 173.6.
What if you divide by 434?
That would be really, really bad. Because you wouldn't get x by itself. You'd be loading x with more stuff. When actually you want to get rid of the stuff it has. You want x by itself. So you want to focus on getting rid of that. This dude is sitting there going, I'm ready. Whatever you do, I'm ready. So that's what you do.
So that's miles, right?
Miles. I love it. Because this is inches. I know inches. And on the bottom is miles. So this is 173.6 miles. Cool. So depending on how you drive like you're going to LA, it might take you very quick. That's what I'm saying.
1 hour.
10
miles an hour.
Now we've moved to Germany. All right. Autobahn. You guys starting to get a feel for this? I mean, cross multiplication is not a difficult process. Setting up ratios is more difficult, but even by itself, I should be able to, this ratio I can totally set up. And then they're always going to give me half of another ratio, and then the other half I don't know.
So you just match the position of the half.
Yes.
You match the position of the half that they give you with the first ratio.
Do it again.
So
Yeah, if I put inches over miles,
yeah,
this has to be inches over miles.
One or the other, you put it in the same position. But how do you know it's inches over miles again?
You don't. You set it up. So, real quick, guys. I could have wrote this. 70 miles in reality is 2.5 inches on the map. But how would I set up this ratio here? 6.2 has to go bottom because I just said inches are on the bottom.
Is there a method to the madness of how you, like, one way would be better than another?
Well, why is this way a little bit better? Because the x is on the top. And in one way that's actually better. But if you always cross multiply, it does not matter worth anything. Because the x is going to come up top wherever that, it's going to be up top no matter where it is. Everything's going to come up to the top, right?
Yes, instead of putting the x on top.
Well, here I cross multiply, the x came up. Here I would cross multiply. What was that? 434. Yep. Right? And I get the same exact equation.
How do you get to 173 again? 160?
Oh, how do I solve this equation? Why is the x not by itself?
Divide by 2.5.
You divide by 2.5, and if you do 434 divided by 2.5, you get 172.6. Because that's the x equals that thing. Okay, maybe. Alright, let me let you guys try one on your own. I've been talking way too much. Like what else is new? Is there anything that you guys got here?
Yeah.
So. Okay, alright. I don't know if they have any Cubs fans, but a Cubs player on average gets, or a certain player gets 3 hits for every 8 at-bats. Yeah, I was waiting for that. To see who loves the Cubs and who doesn't so much. Yeah, what does it mean, by the way, in baseball? Anybody watch baseball?
Yeah.
So if you have a 300 batting average, what does that actually mean? You guys know?
300 means you get 1 out of every 10.
So when they say 300, it's actually 0.300, right?
Yeah.
And I don't need those zeros for math. So 3 out of 10. So for every 10 at bats, you get 3 hits. And that's pretty damn good. So 3 for every 8 is like, dude, you're on a tear. Right? Now, if you don't give a shit about baseball, you can just focus on the numbers. It almost doesn't matter. I can say 3 blurbs for every clip-clop, and you write 3 blurbs over 1 clip-clop. Whatever the hell that is. So then they're going to say, all right, if I go to bat 40 times, I guess I'm the Cubs player. If I was playing baseball, I would get like 3 hits for every 1,000. I don't play baseball. This person goes to bat 40 times. How many hits do they get? If they keep that streak going, how many hits would they get? So try to do that. Don't say anything out loud. Try to do it. So you set up the ratios. All right, so let me catch up to you guys. How do you set that first sentence up as a ratio?
3 over 8.
3 over right?
Yeah, good. 3 hits to 8 at bats. So 3 to 8, taking the units out of the way for a minute. But I got hits over at bats. So how do I set up the second sentence? How do I set up its ratio? Yeah, I know at bat is 40, so I know that goes in the bottom. At bat's on the bottom. The number of hits, I don't know how many hits. That's X. Cross multiply. Some of you guys might notice there's a shortcut on this one, but let's just do it by the book. So if you, how are we doing so far? Is that cool?
40 by 8.
Good. 120 equals 8x divided by 8.
We get 15.
15. 15 what? The shortcut on this specific problem is because 8 becomes 40 very easily. 8 times what is 40? So if we multiply this by 5, you better multiply that by 5. 3 times 5 is 15, right? But if the numbers don't go in, that's when you got to cross multiply and do the math to see what the weird decimal is going to be.
What was that again? Can you do that again?
This is the, back when we were saying, like 2 sevenths becomes what over 14?
4.
Because 7 goes into 14, you just...
Yeah, whatever you do to the bottom, you've got to do to the top also, right? So how did I go from 7 to 14? Multiply by 2. So on the top, I'm going to multiply by 2. Do you see that? The thing that as a student you don't realize is that you're allowed to do that there. If it goes in evenly, hell yeah, it's a beautiful shortcut. It's just not always going to go in evenly. If I would have put a 41 there,
Yeah, it doesn't go.
screw that. It would come out close to 15, but let me do the math and see what it comes out to
They
be,
don't have
right?
to worry about the X then if it goes in?
Yeah, because it's my unknown, but I'm just leaving it as a blank. So you can still put an X there, but then this says that 2 times 2 must be X. Well, for this problem here, not for that. Here, this would say 3 times 5 must be X. X is 15. If you don't quite get that, you can just always cross multiply. It's got to work. But it's a beautiful shortcut if you see it. Okay. That's how most of the problem should be. That number 30, definitely the hardest problem in there. Just got to push you sometimes, right? Don't push me too much, John. Alright, so real quick, I want to talk a little bit about square roots and then I'm going to let us out of here early. Because today has been really heinous.
Yeah, I had to go to work today.
What's that?
I had to go to work today.
Me too. Oh. This semester I teach at 12:30. That's the earliest. Next semester I'm teaching day. I can't do the night anymore. Alright. So what do we already know? Anybody already know things about square roots? What if I ask you this? How many people can tell me what the square root of 49 is? Why is the square root of 49 7? Good. Because a square root symbol actually represents a backwards question. When I see the square root symbol, it says, what does it take 2 of to multiply to be this? So, of course, 49, it takes 2 sevenths to multiply to be it. Right? How are we doing so far? Great.
I understand that.
Now, so what about square root of 100?
10.
Beautiful. So it's all about internalizing the question that the symbol represents. Math is a foreign language. In fact, it's a shorthand foreign language, even worse. We have to understand that one symbol means what does it take 2 of to make the thing that's on the inside. Now, we just don't want to write all this shit out as math people. We're like, screw that, symbol, done. What sucks is the symbol looks a little bit like a division symbol, right? The written out long division symbol, you with me? Or not. Is that only me? Doesn't it look like a division symbol? That's the square root of 14. That's 7 into 14. Ah. But if it doesn't bother you, that's fine.
You said the symbol is, what is it?
What does it take 2 of to multiply to be the number on the inside?
It's also 10 times
Beautiful. It takes 2 tens to multiply to be 100. So it's really, a square root is the opposite of a square. Because what is 7 squared?
49.
So see how a square root undoes what a square did. A square takes 7 and makes it 49. A square root takes 49 back to 7. So whenever you learn a new function, you have to relate it to or learn its opposite function. So we've known squares before, but now we know its opposite, square roots.
How about when you got a fraction?
Huh?
How about when you got a fraction?
Shit! You're in my brain. I don't like that. So what about 9 over 25?
3 over 5.
You got 11. It's almost too easy.
3 over 5?
Yes, exactly. Because don't think that it's going to be harder just because it's a fraction. What's 3/5 times 3/5? 9 over 25. So you can treat top and bottom separately. What does it take 2 of to make 9? And multiply by 9? 3. Over
5.
2 5s make 25. You multiply. There you go. Yes, sir.
What about the numbers that you can't find, like
It's beautiful.
square root for it?
I like it. So there's 2 kinds of that. There's something like the square root of 38.
6 times 6, 36, remainder 2. Is that what you mean?
There's no remainder for this. I like the thought process. But you can at least tell me it's between what 2 numbers? 6 and 7. Why is it between those? Because 6 squared is 36 and 7 squared is 49. So it's got to be between 6 and 7. So if you have a square root button in your calculator, if you do square root of 38, it's going to come out to be 6.1 something maybe. What is it? 6.164 blah blah blah. So that's one kind of root.
6.1.
Second? Yes, 6.1 blah blah blah. That's one kind of root that we can't do by hand, but it is doable. It's a number. And we should know by now that not everything comes out nice. Most square roots come out ugly, meaning they're decimals that never end. So if it's a root that I can't do like square root of 49, something like square root of 38, the answer is going to be some decimal that goes forever. You guys kind of with me?
Yep.
Those that are paying attention? All right.
Yep.
Some of you guys are doing something else. Here's an evil one. Yeah.
Is there a way to do that, like, without using a calculator?
There are ways to do it.
Okay, so for test purposes,
No.
you wouldn't
No.
have a calculator?
For you have to be in calculus, math 180. That's where we learn a way to do this by hand.
Everything seems so complex.
I know, but I want you to realize that it should be weird to undo squares because there's such big gaps. 6 squared is 36. 7 squared is 49. What about all the numbers in the middle? They should have something that squares to be them. And sure enough, if you take this number, and how long does it go on for? For freaking ever. But if you square it, you'll get 38. It shouldn't be pretty. It should be something weird. Right? Because if I take 6.5 and square it, somebody help me out. What's 6.5 squared?
13? Oh.
42.25. See how it's nice? It stops. So if you take any decimal that kind of stops somewhere, you're going to come up with a decimal that stops. But to make a whole number by multiplying a decimal by itself, it's going to probably be an ugly decimal that goes a long ways out forever.
So how far are we going to carry it out? Forever?
I'll tell you. Yeah. But this would be a problem that you would do on your calculator. There's no way to do this by hand. So maybe that's what you're worried about. I could not say, don't use a calculator and tell me the square root of 111 is. You have every right to not do that problem, right? Because no. I will ask you, approximate this, and your answer would be somewhere between 6 and 7. So if I said, what is the square root of 90? What is that between?
9 and 8 or 9 and 10.
Between 100 and 90.
Yeah, what's below 90? That's a perfect square.
81?
81. 81 is 9 squared, so it's between 9 and 10, because 10 squared is 100. So 9 squared is 81. 10 squared is 100. So square root of 90 should be between 9 and 10. Does that make sense visually?
Yep.
It's between those two numbers, so it should be between the two square roots. It should be between 9 and 10.
Can we guess them and be like 9.3?
Yeah,
1.2?
you would most likely be wrong. Because it's really weird to figure out how it builds as it goes through. Somebody help me out. What's the square root of 90?
9.3.5.
9.35?
Yeah.
Yeah.
I was close, huh?
Dude.
Oh, shit.
Alright. So that's two examples of a square root that you can't do by hand. Right? Here's an example of a square root you can't do. I don't care what the hell you got.
You can't.
And you guys try to figure out why.
Because it's negative.
But go on with that. Why is that a problem?
Because it can't be negative.
So what do you multiply by itself to make negative 16? Well, if you think the answer is negative 4, what's negative 4 times negative 4?
16.
16, shit, not negative 16.
Okay.
So there is no number that multiplies by itself. Let me say it like this. There is no real number that multiplies by itself to make negative 16. And the next level of math, you'll talk about numbers that are not called real. This, the answer is no real number. Yes, that's what I'm talking about.
Lovely.
And it's just a stupid decision of a name.
That's not math 90, is it?
Yeah, the very no, it's right. We moved it into 103. It used to be the very end of 90, but now it's in 103 and 110. Before I let you guys go, I want to push it a little bit more than the book does, just because I always do. So get you ready for a possible bonus question. So I want you to understand this. There's an understood 2 here. And why does that make sense? Because the question is, what does it take 2 of? And we just don't write the 2 because if it's not there, we know it's there. Sort of like if I don't put the 1 underneath something, I still know it's there. So what the hell do you think? What the hell is that? That.
Still.
Cube.
Yes, the opposite of a cube. So the question would be, what does it take 3 of to multiply to be 8? I love it. 8 is 2 times 2 times 2. So the cube root of 8 is 2. So you can extend this idea of square roots to cube roots, 4th roots, 5th roots, 111 roots.
Why would you want to do that?
Huh?
Why would you want to do that?
Because it happens.
When?
Huh?
When?
More often than you realize. So many, trying to predict the weather. So many things that happen that we try to model with equations require cube roots and 4th roots. That if I want to solve those equations, let me be careful. They have cubes and 4th powers in them. So if I want to solve them, I have to use cube roots, 4th roots, 5th roots.
Is only the 2 not written, but if it's cubed or 4, then
Exactly.
3 or 4?
Exactly. I like it. So it's only the square root. That's the one that we use most often. That's why we don't write it down.
Kind of like the one's not written. You know?
Same idea.
And the plus sign's not written. And
Exactly. But the negative sign is.
Yeah, what else don't you guys write?
Very well done.
You have no idea.
So if there is no one, start from 2 and up.
Good, because the first root would be kind of silly. If I did have a first root, it would say, what does it take 1 of to make 11? So we don't have it. Right? Because it'd be like, it's 11. Right? So why even add the symbol if it doesn't do a damn thing to it? So that's a good question. We don't have a first root. Because the question will be, what does it take 1 of to make this? This. Right? It'd be kind of a silly, because we don't have it. It's a good question, though, but we don't, there's no need for it. Cool. All right. That's it. We'll get out of here nice and early.
Thank you.
Enjoy it.
Well,